It's written 2 p.m. It's 1:59. So. Don't tempt me. All right. Thank you very much for being back. I see that the dessert table is empty, so I understand why you're back. So, anyway, jokes apart, we'll now shift to the industrial part this afternoon. So, let's now get from this discussion around research and the printed system to see a bit how we can get not only from research to higher TRL stages, but also to the market. So let's put the emphasis on the application part of the value chain. And for that purpose, we'll have a few presentations, and we'll start with Johanna. I will not introduce you once again, Johanna, because you're a superstar now. The idea was for you to bring in the automotive slash, I would say, enabling safer modular EV perspective to the discussion. I think you have a presentation on spot, and then I will call on the next speaker. If that's okay with you. But of course, I move out all my stuff first. Don't bother.
Okay. Yeah. Hello again. So I will present now the results from the automotive prototype work package within VERSAPRINT with the title Automotive from Cell to System Enabling Safer Modular EV Batteries. So what was the challenge for us? As I also explained this morning, and we heard a lot about it, there are rising requirements regarding energy density, safety, manufacturability, lifetime, and sustainability for the battery packs of the future. And the problem here is that many super innovative solutions just don't make it into the application. So they're really great ideas, but due to shrinking development timelines and high cost pressure, they will never make it into the market, even though they might be the best solution, as Bruno also explained earlier today regarding the solution with the titanium. So good idea, but didn't make it, unfortunately. So the challenge here is to develop building blocks into realistic module and pack concepts, including also the validation process. So this is super important. If it's not validated, it will not make it into the market. So what is the benefit here also for the industry? It's reducing the time from the idea into the automotive ready battery application. So this is essential, and this reduces also the development risk for the OEMs. If we can provide already ready to market solutions, for example, and it also shortens the time to market procedure here. So with this challenge, we are moving towards the requirements and KPIs. The automotive use case that was used as a benchmark in this case was provided by CRF. It's a vehicle that's already on the market. You saw it in the slide before. And this is the outer shape of the battery pack that you see on the left-hand side. And on the right-hand side, it's probably a little bit small, but these are the specs of this battery pack. You see here, this battery pack is, for this battery pack, there's an NMC technology used. For VERSAPRINT, we used LFP battery cells. And the approach was now to reach the same specs with the VERSAPRINT automotive battery pack as for this benchmark technology here. Then there are also, of course, some, let's say, basic requirements. I talked about this earlier regarding safety and robustness of the pack or the module. Of course, cost, we talked a lot about costs already today. And weight and cost is sort of the same. And of course, the solution has to be compliant with automotive standards, because if it doesn't meet automotive standards, it will not make it into the market. The key performance indicator in this case are dealing also mainly with electrical, mechanical, and safety standards, also for the battery pack. And also we're talking about process robustness here. So the solution has to be, we need to be able to manufacture it also on an automated scale. Yeah, with this we will be able to transform the approach also into the battery application. So what did we then actually do in this work package? On the left-hand side, you see the inputs that we used for this work package. So there's, on the one hand side, the generic module that Lionel explained earlier today, and all the BBs that you also saw this earlier today. All these solutions are serve as an input, as well as the simulation models that were also used for the generic module. And we also used a tool-based pre-concept. What is a tool-based pre-concept? In this case, we used the FEV BUD code tool. That is a MATLAB-based tool, and for this tool, you can, as an input in this tool, you can throw in the geometry of the battery pack that we saw also on the slide before. So what is the space that we have actually available in our application to fill up with batteries and everything around it that is necessary. Then you can also use as an input the cell characteristics, so shape of the battery cell and also the electrical properties, and maybe also the target that you want to reach. And this tool then calculates possible solutions to meet your targets, or how you could, and shows you also how to shape the module and also the pack. How do I arrange my modules in the pack, and what are the characteristics, calculated characteristics that come out of it. And with this you get an idea about the pre-concept, and then you can refine it into a CAD 3D model. On the right-hand side, you see what came out of the, let's say this is already the best solution, so we had a lot of possible solutions. The best solution that came out of this tool, on the top you have a visualization of this module, also with placeholders for the BBs you want to use. You can just create boxes with the sizes so that you're sure you have the enough space in your later design to place them, and you already see the shape, amount of cells, and in the table you see the electrical characteristics calculated that come out of it, and then you can compare it and see, okay, is this the right solution for me? So this was the pre-concept we were going with. This also serves as an input then for the design and assembly phase. So with this input we designed the module, made a real 3D model, and also from the pack. We derived the 3D data out of it, and we manufactured 3 prototypes that we used then for electrical, mechanical, and safety testing subsequently, and also the 3D data serves as the basis for the simulation tools this is what we did in the validation phase. So what are the results? On the right you see the actual design of the automotive prototype. So you see the 3D printed casing. On the bottom you also see the battery cells. It's cut through this module. So you see the battery cells in between the BB1, so the cooling structure. You can see the bus bars on top connected to the battery cells. And what you also see is the tubing in this case, So this is not an industrialized solution, of course. This is why I said this is the design for the prototype. So we had to make sure that when we build the prototype that it can be implemented into the test benches. And for an industrialized, if we want to put this module into the pack, we would use a cooling distribution plate on the bottom, let's say like more or less in a conventional one, and let's say plug these modules into this distribution plate. And of course, do not use such a tubing because it will leak, definitely, at some stage of the lifetime of the pack. Okay, so what did we do as a result? We designed the module, we designed the pack, we integrated the BBs that were developed within the VERSAPRINT project, and brought these prototypes also into testing. And what we did see is a good correspondence between the CAD design and the final actual physical prototype. We also identified a few design trade-offs, of course, related to the integration of the different components, the robustness maybe also, and also during the assembly. But all in all, we demonstrated that the integration of the BBs is feasible and that it's successful and that it contributes to the performance and the performance of the module and the pack. Here on the bottom you see the final design of the whole pack. So in this case we had 16 of those modules integrated into the pack. We have a few structures to support the strength of the whole frame. So the frame would be also an aluminum frame. We've got bus bars connecting the modules and everything else that is needed, so electrical components, fuses, etc. This would be placed in the box on top of the pack. If you try to reimagine the original design, also in this there was the EE box placed on top. So I left it out in this case to see how the modules are integrated into the frame of the pack. So what do I want you to take home at this stage? So VERSAPRINT demonstrated that successful transfer of the developed BBs into the automotive relevant modules and packs were possible, and the validation was basically included in this way. And not only new materials contribute towards a safe and sustainable battery system, it's also about a systematic design and integration, and also the testing and validation is super important. Then the BB-based and tool-supported approach contributes also towards an efficient technology transfer into the automotive application, and funding project like this one here that connect innovation, integration, and the validation, they actually serve to accelerate industrial readiness and impact. So next steps in this case would include further validation and scaling towards series relevant battery design, because of course this is still on a lower TRL level, but we are walking towards the right direction. Okay, that was my last slide. I hand over to Pierre again.
Thank you. Okay. Thank you very much, Johanna. Yes, please don't go too far. Is there any question or comment so far? If not, I have one. When you mention next steps for the validation and so on, what do you think in practice? What kind of validation are we talking about? First of all, maybe in the microphone.
Yes. First of all, scalability and validation. This is also something we talked earlier today. We need validation processes for all different components. But if we are developing these BBs further, we need to validate them, and we need to prove that they can actually withstand the real application, because if the OEM is coming towards us and saying, okay, I need a solution for this, and we propose one of these solutions that we are developing here. Then the first question is cost, the second question is timing, and the third question is, have you done it before? And so for this, we need to be prepared, and it needs to be validated.
Okay, so more towards system validation and updates.
Yes.
Okay, thank you very much.
Welcome.
Any additional question, comments? Then thank you, Johanna. We'll go then to the next speaker. And here we'll go from ground to the air. I will ask Michel from SONACA. And I will not introduce you again, Michel, because I think you were quite visible this morning. And here you bring the aircraft perspective.
Thank you. Okay, so just to remind what we have discussed this morning regarding the challenge in the framework of this project. So, as you know, the first objective is to find power to cover anti-icing functionality and to develop the dedicated battery. So, as you can see there, we start from the cells up to the module integration in the fuselage bay. So, that's the challenge in the framework of Work Package 7. Linked to the relevant regulations that we have to follow to develop a safety solution compliant with main aeronautics standard in representative environment. And then we would like to integrate here, to integrate different functionality at different level, I will say at module level up to aircraft level. In a dedicated reduced space allocations. So that's a very important challenge for us because as you can imagine, we have a dedicated geometry to follow, aerodynamic constraint to cover, and we would like to demonstrate what we have developed with the different partners to cover all these challenges all together. Then, regarding the aeronautic constraint, it's more focused on very simple criteria, I will say, like temperature, pressure, variation of temperature and pressure during the flight. Reduce space allocation, where the objective is clearly to put the battery close to the functionality. If you put the battery in another location, then you have to put additional cable, additional weight, additional cost, and so on. So regarding the safety approach, for sure, we have seen this morning that some dedicated points need to be put under control. And in service condition, fast charge to cover, because we need to reduce the time on the floor between two flights, and that we have to consider it to be sure that at the end this solution will be validated by the company. So regarding the approach, it's quite in line with what we follow, in fact. So the first point was to define the KPI at the beginning of the project with the relevant constraint. Then we start with the different partner. So we keep in mind the design developed for the generic module, and then we start to develop a dedicated module design according to our constraint with EFESTO, and we perform some stress and thermal analysis to validate the behavior of this module according to our main engineering constraint. Based on that, we, with EFESTO team, we produce different prototypes. Okay, and when these 3 prototypes has been delivered, we have started the full characterization of this solution. So a partial characterization, I will say. The first one is linked to the environmental condition. The second one linked to the mechanical performance in shock and vibration. Initially, we have performed some simulation in static and also in fatigue to be sure that we will have no major issue. And then we perform some shock and vibration test to compare it with our stress simulations. Regarding the electrical characteristic, it was performed with FEV team. They are specialists for this dedicated characterization, and that's the reason why we work with them to characterize the solution correctly and to cross-check if we are in line with our technical requirement. And the last point was done with CEA for the thermal propagation TP test, where we have found very interesting behavior to put under control. So after this characterization phases, we have started the upscaling phases to integrate several modules inside the fuselage, I will say. So it was a decision to deliver a solution in fuselage application based on the fact that we have done initially a dedicated analysis on the wing itself, but we have no enough space to cover the functionality on the wing itself. That's the reason why during the project we take the decision to switch to a fuselage bay application with additional constraint, I will say. So it's the phase 4, and regarding the phase, the task 7.5 is linked to life cycle assessment performed with the support of LOMARTOV team. Very interesting approach also, and we learned a lot regarding what we have to put in place and which criteria we have to put under control to define a LCA picture. So to sum up with some results, as you can see here, we have performed some stress analysis at the module level to demonstrate that and to be sure that we will have no issue during shock and vibration solicitation. We have some graph here. We can go further in detail if you are interested to check where we are regarding this solution. So as mentioned, we know that this support is not well optimized for the application. In this case, it's an answer to an existing problem that we have met on the casing itself. So to be sure that we will have no strong failure during the test campaign, we take the decision to reinforce the structure, the inside structure, okay, and to be sure that at the end we will have a good behavior during shock and vibration during acceleration test campaign. So based on that, we have performed some thermal simulation analysis. Two main steps. The first one is preliminary thermal analysis to cross-check the max temperature that we will have at module level. And the second point was to simulate the cooling system, okay, from the cells to the module level. And then we have followed this approach also up to the full battery pack. It was very interesting activities and new activities for SONACA. We can do it for airframe, not a big deal for us to do that, but we duplicate a similar methodology of what we have already certified for hot airflow, and to compare it to cooling systems that we have hit. And it was a very interesting point for us to develop this expertise for the cooling system. So as mentioned this morning, it's quite similar to what we have seen this morning, but its main key results linked to the three main steps: structure validation of structural behavior. The second point more focused on electrical ones, and the third one the TP test. And based on these three main test campaign, we have drawn some conclusion here. regarding the attention points that we have to put under control if tomorrow we have to switch to industrial solutions. Combining to that, we have developed also some plug-and-play approach. It's very important to produce this type of structure. It's not so difficult, but to be sure that we can remove it easily in service conditions, that's a challenge, in fact. And we have a lot of movable interface with the relevant design tolerances. And in this case, for sure, the objective is to develop a cost-killer solution, because it's clear to develop with extruded section. It's quite easy again, and with a quite limited cost. But to have develop an ergonomic solution for the end user, that's again this challenge, and we have target cost to cover. Even if we switch to an electrical solution at the end, you are in the market or not in the market. If you are out of the market, not necessary to continue. Okay, so regarding the plug and play, and we know that the plug and play approach, it seems to be easy, but it's not really the case, in fact, and all the hardware linked to the plug and play solution cost a lot. So it's also an important point for us. When you develop a removable solution, then the cost will be higher comparing to a fixed solution. So here we have put in front of regarding the venting functionality and electrical ones. We try to develop simplify interface, I will say, between the electrical system and the structure ones. And for the other one, it's more focused on a cooling device. So it's specific hardware covering cooling system. As mentioned by Johanna, I agree with her regarding the fact that what we develop for the project, we will have some leak issue in service configuration. But for the prototype, it's enough. So we have identified link during the test campaign, so it's clear. So we have an additional point to cover. But anyway, at the end, it's one dedicated point of the project. But for sure, if tomorrow we have to develop a qualified and certified solution, it's clear that we have to switch to another type of standard for cooling system. Okay, regarding future outlook, regarding the weight assessment. So it's quite clear for the moment. The total weight is close to 1.5 tons. Okay, we have all the detailed information here. It's clear that we have some improvement to put in place and to consider it. We are quite confident on the fact that we can decrease of 30% the total weight. Okay, so close to 1 ton. And according to our understanding, if tomorrow we can develop a solution for this dedicated functionality close to 700, 800 kilograms, it should be okay. So we have to divide it by 2. And as you can see here, you have a good major contribution of the cell itself. Okay. So for us, we need to put resource here to optimize at the cells level. It's clear regarding the structure itself, some improvement can be implemented, but the major point for us will be to challenge the cells itself. And for sure, if we challenge the cells, we reduce the space allocation, then we can select another location on the aircraft. So we will have less copper cable and so on. Because if we have a functionality on the wing and you have the battery in the fuselage, you will have some kilometers of cable and additional weight and so on. So for us, the major point is to miniaturize the battery, I will say, to be sure that we can put close to the wing, and then the target to reduce by 2 the weight For us, it's not. It should be possible to do that. Regarding yes, the integration. So what is what I mentioned here? Okay, so just to give you the picture and regarding the distance on a commercial aircraft, for sure, for a two-seat aircraft, no issue to. Not necessary to discuss. If you have 1 meter more of cable, it's not a big deal. But for a commercial aircraft, it's some few hundred meters of cable. Okay, that's the second. That's the last slide. Yes, regarding the cost itself, again, it sounds good. It's not so expensive, I will say, for sure. We can optimize it. Okay, it's a preliminary estimation at module level. I'm really sure that the cost will be driven by the quantity, in fact. If you have a very specific process, when you will upscale the manufacturing process, naturally the cost will be decreased, and if you can increase the quantity to produce, to have standardized part to produce, for sure we can reduce the relevant cost. And as we discussed this morning, it's clear that who will pay for that? It's a good question, but I'm not sure that the end user will not be the only guys to pay. Okay, thank you.
You just killed my first question to the panel this afternoon. So, okay. But thanks a lot, Michel. I just had I just had a quick question. When you say scaling to reduce the cost, does it apply also to the plug-and-play components that you described? I mean, would it be scale enough to reduce those costs dramatically?
But in fact, comparing to automotive industry, the scale-up is not similar to what we have for aeronautics industry. But for plug-and-play solution, we have a lot of standardized solution in the market with reduced and optimized cost, in fact. So for this typical type of hardware, we have a lot of suppliers on the market to produce this component for us, so it's not a big deal, but the associated cost for this type of hardware is not a big challenge. If you have 2 or 3 players and you have 2 or 3 competitors, and then you can play with them. But we can discuss with them. But at the end, the cost driver will be an important key parameter for all of us.
Okay, but more on the sales side than the rack, basically. That's your message.
Yes, it's clear. It's clear. The extra cost will be at sales level, not at the structure level, because we have a lot of quantity. For example, for aluminium, titanium, and so on, the raw material, the cost of raw material, according to the situation, worldwide situation, but if you have contract covering 5 years and so on, the price is quite stabilized, in fact. But for battery, I'm not sure if we are not able to produce a part in Europe. For sure, you depend of different countries, and the cost will be variable according to the need, in fact.
Yeah. Well, as long as we stick to current chemistries, right? That's maybe an element of transition. Thanks a lot, Michel. I will now turn to a new speaker, Alfredo Cota from EFESTO. Alfredo, I will take the chance to introduce you. You hold a master's degree from the University of Torino from 2019, and you're finishing your Politecnico di Torino PhD in electrical engineering. You focus on the new perspective of DC networks and electric vehicles in particular. And of course, you have, like a lot of people around the table, experience in EU projects, and you participate in many of them. Floor is yours.
Thank you very much.
Up to you.
Okay. I can just leave it here since I have it in my... Okay, so first of all, nice to meet you in person. I came, during the project's duration, quite at the end, so I never got the chance to meet you in person. Sad that the project is ending now, but I think we did a good job. So,
You just need to win a new one.
yeah, why not? I mean, hopefully, and see you again there. So, for our, this is the clicker, right? Green one, okay. So our topic of discussion in this case is the replicability to other applications, tailored battery designs for harsher environments. We touched the topic of automotive applications. We touched the topic of aeronautic applications, now with Michel. What's harsher than a boat, probably? So, yeah, during the activities of Work Package 5, we focused on different scenarios, and EFESTO has an expertise, a direct expertise in the hybridization of boats, namely the use case that we wanted to share with you, and we worked on this, is the hybridization of Venetian taxi boats. So here the batteries endure simultaneously electrochemical corrosion, mechanical stress, and thermal confinement. So I guess that indeed qualifies as a harsh condition. So every vessel has unique volumes, must have different requirements for each application. So the challenging part was basically trying to provide a do-it-all solution thanks to some fixed requirements. At sea, of course, you have evacuation problems, and you have all the other, spatial constraints of a vessel. So indeed, safety was also paramount to be kept intact, compared to automotive and other types of applications. So what we did during the project in the activities of Work Package 5 was to identify the necessary requirements and KPIs that we had to respect in order to produce some good results, and the consistent results especially. So not only designing the battery pack, again at simulation level, no physical prototype in this case, unlike what was presented previously. The design had to be rugged enough for ocean and marine contexts, but flexible enough thanks to the VERSAPRINT approach. And it had, of course, to integrate the building blocks developed in the first part of the project. So here you can see a long and comprehensive list of the requirements that we identified. And as I stressed before, the safety and the resistance to water corrosions, sticks out as two of the main, requirements that need to be respected in this simulation that we carried out. So our approach was to try and draw a line between the different compromises that we needed to analyze in terms of integrating these building blocks of VERSAPRINTs into a marine battery pack. So we drew the line, we identified some target requirements that we needed to fulfill and respect. And I think we managed that in terms of simulating a good application. So this was done mainly thanks to the support and iteration of some parts of the simulation tool that were developed during the project, and our own elaborations of that. So it was a continuous iteration process between different partners of the project. And this is basically the result, the outcome of what was defined in our work package. Again, the main idea was not compromising performance only for the sake of integrating the building blocks, without, again, a focus on the requirements. In terms of results and discussion, here you can see a rendering of what was achieved in these simulations. So the configuration is 12 16-cell modules with prismatic cells, liquid cooling, polymer-based housing, and an external gas exhaust, which defines basically what was mentioned before in terms of requirements and building blocks integration of the project. So this virtual prototype reached the target voltage, power capability, energy capacity, while integrating all the protective measures that need to be integrated in a marine environment. So including IP67 sealing, which was of course paramount in this regard. So basically it proved at, again, a simulation level that we could actually integrate our building blocks in such an application, which was, not to be taken for granted probably. Again, focusing more on the VERSAPRINT project topics, so the building blocks development. Here I listed the 3 building blocks that were included in our architecture. So all the design choices, again, were including these building blocks. And yeah, I mean, you know them very well, so I'm not gonna further take time on this. But yeah, they provide good performance indicators such as low weight and corrosion resistance. Again, paramount, I'm not stressing that enough. So the efficient cooling, again, was paramount because of the cramped conditions of the Venetian taxi boat. And also for the bus bar connectors, the easy-to-cut bus bars were selected for the adaptability and the ease of assembly during maintenance operations that in such vessels are very frequent, so to say, because of their, old nature. A future outlook I wanted to also share with you, but Michel presented it before, some other iterations of the VERSAPRINT project that were carried out by EFESTO. And all in all, on one side on this simulation, on the other side for the aeronautic application with physical prototypes, I believe that we can draw a line, a positive outcome of the project application of the building blocks into these battery pack applications. So I think the future could be bright for such concepts and applicating them into, more large scale adoption iterations. So yeah, this is my presentation.
Excellent. You're only good student so far, I must say. Very glad to see. Any question for Alfredo so far? Comment or anything? No? I mean, I like no comment and question. It means that everything is crystal clear. So
Yeah,
very
hopefully.
good. Thank you very much, Alfredo. We've been speaking about land, sea, air. Now, of course, across all the different areas, nothing comes without sustainability. And in that respect, I would like to welcome Marco Bianchini from LOMARTOV. Marco, you're coming not as a moderator, but as a speaker, so I must introduce you now. And you're a material scientist with quite a lot of expertise in advanced materials and energy applications. And in 2023, you joined LOMARTOV as senior engineer, where you lead sustainability and exploitation activities for innovative projects. Right now, you will talk about eco-design, LCA, circularity, basically about the afterlife, right? Somehow. Please, Marco, join me on stage.
Thank you very much. Yeah, sure. Won't be distracting. Thank you, Pierre. Hi, everyone, again. Yes, so as you introduced, I'm going to talk a little bit about sustainability, because if it wasn't stressed enough, is a key point in VERSAPRINT development, and something that we took in mind from really writing the proposal to all the R&D activities to the very end. And it's not just about afterlife, but I would say it's from before a product is born to during all its life to the afterlife. So it's actually a very transversal topic that touches most technologies, and in this case now we're talking about printed battery systems. So first of all, I wanted to tell you a bit about the challenge and the type of assessments that we performed in this project. The first one being the eco-design, so basically the ability to provide a guidance, a recommendation to the partners to basically to optimize, reduce environmental impacts, especially focusing on the environmental impacts, costs, manufacturability, so the scalability also of the solution, and the circularity. After that, we focus on the validation of the different prototypes that were developed in the project, especially on the automotive and aeronautics sectors. We had this close interaction with FEV, with SONACA, and all the developer partners. And here, for example, some of the questions that we try to answer are: how does this technology compares to conventional battery systems? Where can we actually improve, especially thinking about moving beyond the TRL that we achieved? And then how is the system circularity improved, so how we are addressing the circularity, and is this economically feasible? This is a very important question to answer. Last but not least, not again a point one, but the point 3 would be the alignment as well with regulations. As you know, sustainability is becoming more and more important and necessary out of the European regulation. So mentioning, for example, the eco-design regulation, the battery regulation, critical raw material act, and so on. So regarding our activities in sustainability here, some of the requirements KPI that we kept in mind were about the eco-design of this product. So prioritizing, for example, the use of green or bio-based additives and solvents, just referring, for example, to ink formulation. Then the easy-to-dismantle features that you probably already saw the prototypes in the other room. That's also one of the key functions that we developed here. Then improve the level of recyclability, especially related to these flame retardants in our polymer blends. Lightweighting, especially important for industrial application. Extended system lifetime. Okay, so this is mostly thanks to the advanced thermal management that we can offer. And then, of course, as I mentioned before, costs. We have some clear targets in the project, but basically more like to guide us. Of course, TRL5 technology is hard to reach these targets. And finally, last but not least, carbon footprint, something I'm sure you're all aware of, and embodied energy. So basically how much energy we need to produce a product, right? So in terms of methodologies and our approach, especially in the eco-design part, it wasn't straightforward. So we adapted two typical methodologies from the field. The first being the life cycle thinking, as you may know, basically taking into account all the life cycle of a product from the very extraction of raw material, their processing, the manufacturing of the product, the use of the product, and the end of life. On the other hand, we try to mix this with the typical eco-design strategies that we typically use in these fields. So, for example, the use of low-impact material, but using less materials as well when possible. Optimize processes, reducing the weight has a direct impact also on the operation phase. The lifetime as well of the battery, and the end of life, how we manage the waste that we generate, basically the batteries at their end of life. So I just want to show you some results and how these assessments helped us, first guiding the partners in the development, and then finally validating the environmental and economic impacts, okay? So starting from the top left, for example, this is related to the inks that LATAT was developing for the temperature sensor. First of all, we compared what's the environmental impact. The different columns you see refer to different impact categories. So you may know the CC is the climate change, or basically the carbon footprint, as you may know it mostly. But so these are all important categories that we took in mind when performing this assessment. And we compared, for example, the typical solvent-based inks with water-based inks, so with some bio-based additives from LATAT. We could already see that this solution already outperforms the conventional solvent solution, and so for us was like a thumbs up. At the bottom, so we have for example, the cooling system that we developed with the microchannels. what we could see here is that the material, for example, chose until now is still a kind of a high impact material, and a large majority of that impact, especially on the use of metal and mineral resources, come from a very, very tiny quantity of platinum inside the formulation, which is needed then to do this cross-linking, okay, for the polymer, for the rubber. And so that's why one of our messages was to either change the material, try to avoid the use of platinum group metals for this application. And then finally, all these other graphs were just basically performed to help partners define the type of material we could use for a casing. Okay. First of all, we helped the partners with this material selection radar. So we took into account different categories, such as what's the service temperature, the LCA performance, recyclability, flame resistance, and the cost for different materials. Then we compared what happens when we put flame retardant into this blend, okay, this material. And we could see actually flame retardant has a way higher impact into the final material than the polymer, even if the quantity of flame retardant is smaller. Okay, so these are very important results to keep in mind when designing this type of materials. And then finally, what's the impact of the thickness of the casing, of course, because it directly affects the amount of material we have in the casing. And finally, we try to consider the full life cycle, so also in operation in a car, for example. This was an exercise we did to see when we have a break-even in climate change impact, for example, in the global warming potential, depending on the thickness. So we can see like we cannot go beyond with this thickness, otherwise the impact is worse than a conventional system. Beyond the eco-design, as I mentioned, we also then performed a full validation on these two type of prototypes for Aeronautics and for Automotive. So I've just included some examples, especially related to the Automotive, in which top left, I'm showing here what's the whole life cycle impact, including all the life cycle stages, compared to a baseline. Okay, so a typical battery pack that we model accordingly. But also what's the impact of the battery lifetime. So if we're able to extend the battery lifetime, okay, how does this life cycle impact change? And we could see that it reduces dramatically. So it's very important for us to being able to improve this the lifetime. On the right hand, then we have the hotspot analysis, also typical analysis we do at a cradle to gate, meaning we consider raw materials and the manufacturing process, and then we compare traditional battery system with our solution. And there we can see for different impact categories, okay, where are the main hotspots? Where are the trade-offs? What type of materials are actually not fitting because maybe the impact is too high? Of course, we've performed this for both battery prototypes. And then regarding the end of life, in order to understand where all these material we have in a battery pack, where do they go? I think it's nice and visual. We performed this material flow analysis. So we could see we go to a disassembly line, and then all these materials, some are recovered in some more traditional way because we have some scrap metals and stuff, and others goes to maybe some more complex recycling processes, such as hydrometallurgical for even the BMS for the battery, or the pyrometallurgical treatment for LFP batteries. Okay, of course we have impacts related to all of this, which I'm not showing right now. But then I think the last message I wanted to show is about a specific analysis we performed in the aeronautics sector. Because that was a very challenging approach for us, because when you change a typical pneumatic heating system for the wings, okay, where basically the energy inputs come from the same fuel, jet fuel that we are burning in the engine, when you replace it with a battery, there is so many differences in the system, in displacements of impacts, okay? So this was very challenging. The only analysis that we performed here was related to the use phase, of course with some assumption, thanks to the colleagues at SONACA. But we could see what's the difference in environmental impacts when we use this fuel-based solution compared to battery systems, but also comparing different electricity sources. So electricity comes from Germany, or if it comes from France, it's very different. Okay, so that's something that we could compare in order to see what is the entity of savings we can have. And very last slides is related to costs. Okay, again, we also performed a techno-economic analysis on both prototypes, and it more or less it looks like this. So we could analyze what is the impact share for the capex of different equipments we would need in a manufacturing plant, okay, to produce all these solutions. Then again, what is the share of impact for the operation related, so related to the materials that we have. And then, so the objective here was to understand, where the highest cost lay and maybe where we need to optimize. So we calculated the net production cost of these batteries, but also then the total cost of ownership. And that also was part of a challenge for us, because to understand the cost of maintaining a battery, okay, especially in a circular framework. In this circular framework, instead of we have a problem in a battery module, we replace the whole module with a new one. What we do, we take the module, we open it up, we replace only the cells that have issues or that are failing with new cells. So this has direct impacts for the environment, of course, but really it has impacts on costs, because this maintenance can actually provide benefits, as you can see in the graph on the left, in the case of VERSAPRINT, while it's added costs, for an OEM, if they are just replacing the module, okay, because of the cost of material mostly. So this is all from my side. I think it's just an overview of what we've done, but main documents will be available in public. So if you're interested, of course, you're welcome to download it.
Thank you very much, Marco. We need that for each project we have. Truly, every time I see one of your jobs, it's really clear. Question, remarks so far? I see all eyes are open, meaning that you're still with us. That's very good. And I will invite then my panel speakers on stage. Johanna, please. Michel, Marco, Alfredo. And I will also take the opportunity to invite two new speakers. Of course, if my computer allows it. And let me name Abdoulaye Ndiaye from OPmobility. Welcome with us. I will do my job of reading your bio, because otherwise. So you're validation group leader for the battery product line at OPmobility, where you coordinate product testing, validation and homologation, covering abuse, environmental performance, and durability tests. And you previously had roles in quality management, in plan, and in the validation of fuel tanks and SCR systems. It's quite a CV here. And you're joined by, last but definitely not least, Marina Urbina, who is wearing several hats today. Marina, you come to us from CEA, and we've known you in the EU sphere as a leading project manager of EU projects, and you represent CEA, working on today on electricity and hydrogen for transport. Well, I think over a decade is closer than 15 years, if I'm not mistaken, of EU program management for CEA, and you're currently research vice president on the executive board of the Batteries European Partnership Association, BEPA, which is your second hat today. So thanks for joining us. You hold a PhD in chemistry from the Autonomous University of Madrid, and you focus on European research on batteries, hydrogen technologies, and advanced materials. What a great panel. Let's welcome them already with a round of applause, please. I will avoid the stage and leave you alone because you need to debate. But, EU projects can be a little bit boring sometimes for a very simple reason, is that we have a lot of scientific people, around the table. So what does it mean? It means that you all easily agree when there are facts and figures. So let me maybe start with a bit of drama, create a bit of discussion, and linking also the two panels. Michel, you did it yourself, huh? I think that this morning we had colleagues around the table saying the end user should pay for the future, and you seem to disagree. So I would like to just ask you to kick it off slightly with this, just to make you comfortable.
In fact, it's always the same thing. Who will pay that?
Who will pay?
So,
what is your view from the end user perspective?
but in fact, in terms of margin, this morning we discussed about the margin and so on. So I don't know the margin that we have for electrification. I will say to use battery to electrify component comparing to existing solution. But we have to know that for structural aspect, the margin for end user, it's not so large, in fact. So for sure, if tomorrow we have to switch to another technologies, then it's a complete picture that we have to review, not only the end user, but the full line, I will say. So, and to rediscuss the point with all players, from the manufacturer up to the end user, recycle people, and so on. So it's not an easy question, I will say. But just to say it will be the end user at the end is not the manufacturer of the part itself. It will be you when you will take when you will fly and so on. So if you are agree to put 10 euros more at the end for good reason, for sure. But if everybody around the table are on the same page, for sure the solution it's found.
So we shift back to the very end of the value chain, which is really the customers, the end customer.
Yes.
Or spreading the cost along the value chain to everyone.
Yeah,
That's
for
a bit
sure.
The message.
Yes, yes.
Right? Maybe turning to Johanna. Is that something that you do you agree on that perspective?
Yes, definitely. So I don't think the end user is ready to pay for battery cells that are manufactured in Europe just because they are manufactured in Europe. So if we are not competitive regarding the costs, then I don't think anyone, maybe apart from the defense industry, because they have to pay this higher price. But apart from this, so they will not pay for it. I mean, we've also seen it in the past. I mean, especially in Germany, there were a great resistance against electric cars because the automotive industry in Germany is traditionally very strong, and they're really good at building combustion engines, and they really didn't want to develop electrified cars to challenge their great inventions. So Germany turned quite late into the market, and then the electric vehicles built by BMW or VW, they were rather expensive compared to cars coming from Asia. This is still the case, and what we saw is that either the people were still buying combustion engines, or they were buying the cheap cars coming from abroad. So now there's a change in the mind, and also VW is offering cheaper cars, and now we see also a change in the market. Even if we've got a good idea, but if it's more expensive than established solutions, I don't think there's a chance that the end customer will pay for it.
Understood. Unless, of course, at some point you have a dramatic range revolution, or.
Of course,
yeah.
if you have a good reason for this more expensive solution, increased range, for example, or some other comfort, of course, or another unique selling point, then of course, I mean, look at Apple telephones. This is probably not the best telephone or not the best smartphone in terms of technique, but they still have a big market share.
That's a bit the intangible value we touched also upon this morning, right? So we discussed the timeline for a customer to get to it. But okay, for that, of course, we cannot forget the issue of cost. I was wondering from your perspective, Johanna, how do you see the scaling trajectory of those printed systems? can we make it to scale? What are the requirements that you think we need to match for this kind of system to be acceptable by end users?
What kind of systems? I mean,
The printed systems.
The printer
like
system.
VERSAPRINT, for example.
Yeah, we need the scalability. So especially for the automotive industry, we are talking about gigafactories for battery manufacturing. So if we want to integrate, for example, printed sensors, this printing technology needs to be ready to be integrated into a gigafactory. So if we want a sensor on every battery cell, for example, temperature sensor, I mean, they are super thin. They have to be printed in the same speed as the batteries are produced, for example.
Are you suggesting that it's a bit unrealistic right now, or?
It is a great effort, I would say.
You need to put in some more cash then, that's your message? Or?
Of course, cash, but also a little bit of brain.
Yes. How so? What brain?
Brain,
in terms of engineering, in terms of...
Yes, in terms of engineering, of course. You need also, but the supply chain, so you need people for manufacturing the machines, of course, in this dimension. You need the whole process chain needs to be adjusted to this huge amount of battery cells and modules that are necessary, at least for this sector.
Yeah, well, that's okay. That's the EV perspective. I think the EV language that you're adopting here. I remember when we were, especially talking about additive techniques, and when you have those economies of scale that are flat, in theory. That's something that I would really love to hear from you, Alfredo. We're discussing boat applications, so basically maritime vehicles. How do you perceive it? Do you feel that you are on the same level of constraints for the ramp up, this scale up?
Well, of course, like the industry is very different, and also the penetration of the electrification is vastly inferior as of now. But I guess sometimes it's better to start from a blank page than to build upon some maybe bad habits, so to say, that we have maybe identified together today, and we have underlined, and maybe are some of the focus of this panel indeed. So starting from scratch, almost in the maritime sector, albeit with all the constraints that I have highlighted briefly in my presentation,
can you maybe, sorry to interrupt, but just highlight like the top 3 ones, because I understand that corrosion can be key and that you have a big list, right? But if you had to rank like the top 3.
Yeah, well, the temperatures can also vary very much in marine applications. Okay. Spatial constraints are also a theme, even though weight is not as impactful as other of the applications that we were mentioning, and then safety, of course. Since it's much harder to plan for evacuations in a boat than maybe on the ground, not in the air. But yeah, I think these are the 3 main to be highlighted. So if we can integrate these technologies while still respecting the requirements, I think there's a lot of potential on the maritime side of things. Compared to maybe some other further developments in other industries as of now. I don't want to sound pessimistic, but maybe it's easier to get at the same level from a lower so to say industry standard as of now than to make the last step and actually conclude the transition towards EVs at large scale as of now.
In a way, what you say is that the light regulatory weight is also helping you move faster.
Definitely.
Okay, interesting point.
So, for instance, at EFESTO, we have developed this hybrid powertrain for this boat, and again, it's always at prototype level. We are lucky that we deal with prototypes and not, large series and large scale production, but indeed, I think there is a lot of untapped potential in the electrification and hybridization of this, mobility sector, so to say. So I look forward to see what the future holds in that regard.
You still see a complementarity with other technologies like, hydrogen, for example, and other vectors? Or?
I'm not an expert in those, so to say. So I try to focus on what I've got to know a bit better. But I think yes, I think they can be complementary, and especially for smaller applications, the electrifications could come
so
way easier. Yeah, so
light
like
electric maritime mobility.
yeah, like the taxi boat, for instance, is a perfect example. You have to go only in hybrid in the Venetian canals, for instance, because of pollution reasons. But then when you have to make cover a bigger distance, then you can proceed traditionally, so to say. So I think there's untapped potential in there for sure. Yeah.
Okay. I'm thinking that regulation is probably definitely not something that SONACA cares about, right?
Yes, it's clear. Huh? So regulation, that's first topics to consider when you start from a blank page. It's clear, but regulation, with this regulation, you have to put in front of the associated cost.
Yeah.
It's clear.
Yeah. And for you, so I assume that regulatory compliance and safety are probably maybe the top two areas, or do you see others? I was thinking of what it would take for SONACA, but also the Airbus, Safran, Leonardo of this world to adopt this kind of printed systems that we've been presented so far. What would be the expectations, the requirements to make it really to the civil aviation sector, or maybe even?
It's clear that the safety is the first point to cover. No discussion about that.
Yeah, you cannot swim in the air. That's.
No, it's clear. Yes, that's the main criteria for us, and you have also a cost driver. So it could be the second point, in fact, at the end. But regarding the cost, we have several types of costs that you can challenge during the full life of the product. So initially, but as we can discuss here, the European Commission, for example, put millions on the table to be sure that we can sustain the relevant technical challenge to be autonomous tomorrow and so on. And then it will be a strong help for schools, for university, for manufacturer to be in line with the expectation. But the second step is regarding the cost linked to the production itself, so the quantity to produce. And in Europe, so we have different opportunity to decrease the cost and the automation, for example. So yesterday, when we have to kill the cost, you switch to automation, and automotive industry is a concrete example. For Aeronautics 30 years ago, it's a mainly manual operation. Then we switch to automation in Europe, and then to save money, we have to put automation, maybe not in Germany or neither in Germany nor France, but to switch to other country in Europe where we are able to perform automation in, I will say, low-cost area. So to remain competitive, I will say. So we have different opportunity, but the standardization also, it's a strong opportunity. The quantity defines the final cost. And that's the reason why when you start discussion with new OEM and so on, you have two different type of price. The price after it's 1,000 aircraft, for example. So then you can have a non-recurring cost and a recurring cost according to the technologies that you want to qualify, certify, and so on. And then when you are in full serial production life, then the RC cost, the recurrent cost, will be lower comparing to the initial ones. So it's a very interesting discussion, but at the beginning, when European Commission put euros on the table for R&D project, it's to increase our competence, our knowledge, our competence comparing to other countries, to be sure that we can start not from scratch, but from a dedicated level with the relevant technology in front of. And then you can discuss about the price and the associated cost to produce it in Europe. But the raw material, it's also a big question. Initially, that may be the first question before starting the production, to be sure that we can produce the raw material in the dedicated quantity to produce that.
And do you see it as a key risk factor for your company, that we're still here on NMC, LFP chemistries, so nickel, manganese, cobalt, lithium dependent, or?
I'm not specialist of raw material for the battery, but what I know, it's in Europe, we have a lot of opportunity. But the main supplier of this raw material should not be in Europe, or maybe we have to switch to another technology. For structural aspect, for example, it's clear that dedicated raw material, we are one or two big players in Europe, but we have to mitigate the point with different sources, and then in order to stabilize a dedicated price, if you have only one single source, at the end you will pay for that.
Yeah.
So it's a big challenge to solve, and you need two legs to run.
Yes, yes, indeed. So supply chain diversification,
Yes.
stabilize a bit the supply, and
Yeah.
but I'm thinking for the cell itself. I mean, I'm also thinking of the BMS, for example. I mean, in electronics, you find gallium, germanium, which are under Chinese ban, for example. So I would say we have risks pretty much everywhere. Yeah, but maybe just relating to the upscale, Abdoulaye, how do you perceive the position of these systems? So the printed battery systems that we discussed so far. We've been speaking a lot about the upscaling process. We've been speaking a lot on about validation steps. How do you position this kind of system in that process? What's your perspective there?
Thank you for your question. So according to this type of project, for the testing, it is not very different as the other project, because when I put one part in my lab, it could be one bus bar, one pack, or one module. For me, it's the same. But it's a good way, for example, if we have some issue on part, with 3D printed, it's easy to have new parts. Also for the integration, for example, if we want to reduce the BOM, it is also a good way. What can I say more about this subject? We also reduce the cost of this project with that.
Okay. So increasing the value in a way, a bit like
Yes.
what you were saying. Feel free to have the microphone turned. I'm the one, I'm French, so I speak too much. You've seen that already. But let's be interactive. Please feel free to intervene as well. Don't wait for me to bother you with questions. Please, Michel.
But for 3D printing, the main benefit, I will say, it's to complexify. Okay, if you produce simple part with conventional processes, no challenge, in fact. For our point of view at SONACA, we would like to promote this type of 3D printing process, because you can generate complex shape with additional functionality inside. And for us, it makes sense to complexify the part where you are able to integrate more functionality in the reduced space allocation.
Can you give examples? We've seen the cooling channels, we've seen embedded sensors.
But for example, for the venting, it's a good idea to have the cooling system on the cooling system on the cells itself. So printing sensor and so on. So it's an opportunity, and also for the bus bar itself. So complex shape, not only a sheet metal part bended with two welded points, but to complexify and to add value in the product itself. And then you can make the difference between other countries where it's more focused on quite old manufacturing processes with quite conventional way. And for example, for very big quantity, it makes easy to do the job in another country with a simple action on the manufacturing processes. But for us, the added value should be on more complex assembly process and also for composite structure. It's not so easy to produce. It's not plastic part. It's a full CFRP component where you can integrate more functionality inside. And in this case, it's interesting to develop it also in Europe, and that's a big difference between other countries where a more simplified process are available.
Yeah. Do you see it also from the material perspective? We've been speaking about the titanium price and dependency this morning. Do you see, for example, I don't know, carbon reinforced thermoplastics or other avenues to substitute to currently annoying metals, for example, in the back?
We know that when we have to develop new material, new metallic material for a dedicated application, it costs a lot. It's clear. So, and then you have to pay the supplier to develop and to produce this part according to the quantity that you need. But for some specific application, for very high structural application, we have already developed dedicated material for one application. But as you can imagine, at the end, if you consume 2 tons per year, you will pay for 20 tons. And the price will be multiplied by 10 easily, based on the fact that you have no volume, but you need it for dedicated technical applications. Yeah. And with 3D printing process, for example, it makes sense to continue in this way, because if you complexify the part, with a very reduced space allocation for aerospace application, it's a similar approach. And you have very specific material qualified for very specific space application. And it's maybe 0.01% of the market. But if you don't have it, you are not able to produce satellite and so on. And so that's the reason why in this dedicated configuration, we can make the difference between quite more conventional processes. It's clear.
That's maybe I was about to throw the ball to you.
I interrupted you, sorry.
Material saving.
Yeah, exactly. I was thinking.
It resonates.
No, I just wanted to add on this because I'm mentioning particularly 3D printing, which was a key enabler for VERSAPRINT project. It definitely makes sense what Michel said about the complex shapes and some type of applications that wouldn't be possible otherwise, but also. From the analysis where we made, we also know that 3D printing is a good solution, but not for everything. And especially in terms of scale, what Johanna was mentioning, right? So if we want a solution to be able to scale accordingly to, for example, battery production for automotive, which is like huge, pretty much what we could see is that it works better for small parts and less. It's worse, let's say, for bigger parts.
Do you have an example, for example, about where sustainability breaks, so to speak, in the scaling?
No, that's quite hard to say. But it's not really about. I mean, in terms of sustainability, we know it's also a more highly intensive, highly energy-intensive process, the 3D printing. So it's something you need to take into account. Yeah. But it's not. It's something that you could also counterbalance, in the full life cycle of a product. So that's not just a big deal in terms of sustainability. It's great in the sense of waste reduction, because we know that when you're 3D printing, you just need to use the material that you actually need. So that's great, and there's huge associated costs to these to the waste management, for example, the scrap recycling and so on. Okay. So it's definitely also good for some of these topics. I think the conversation here is a bit more about cost. I feel it's getting more.
No, I was actually about
for
to
industrial application makes sense.
Yeah.
So it's something to take into account. It works better for some products, worse for others. Also because it depends pretty much on how many parts you can print at the same time, right? For a huge part that maybe takes the whole printing bed at once, it means that the production is going to be way less depreciating on the capex that you need for the system. So that's something that your production line you will definitely consider.
Yeah. No, I was actually about to also plug you to the sustainability part, not the cost, because I will reserve the cost to Marina.
To ask a
please,
question.
please,
I know
Marina.
that I'm not here for asking questions,
but
since you said that, VERSAPRINT is about additive manufacturing, maybe it is the case for niche applications, because niche applications, so far, they don't need big deployment. So this could be also the case for Europe, since we know that for automotive applications we are a little bit lagging behind, but we don't have to lose space in terms of niche applications that are strategic for Europe, let's say defense, robotics, or others. So maybe it's just an idea, but maybe additive, VERSAPRINT additive manufacturing could be a good asset for these niche applications.
Business reasoning, indeed. Yeah, for the ones that cannot pass the scalability threshold. I think that was something where I was teasing a bit Johanna a bit earlier on this. Where does it stop in a way? And can we make it? That was a bit the question I was teasing you with. But maybe just staying with the cost, because Marina, you have this broader EU perspective. Today we've been speaking about different elements, and we've been valuing the fact that there is this collaboration and a cluster and exchanges, potential for standardization. Of course, everyone cried about cost and the fact that someone should pay. I think that's the main thing. And comes the question of public authorities. And what do? We know that China, but also the US, have been over-subsidizing their sector, right? To an extent that is also beyond legal, according to some commentators. Not me, of course, I cannot judge, but just to say that some say it. So how do you see the position of the European policy landscape? Do you think that we are actually well positioned to scale this kind of technology, to bring it to market, and to remain competitive with China, China and probably China as well?
Thanks for the question. It's a difficult one, but still it's a very good one. It's a very relevant one. So the landscape, the policy ecosystem, the regulation ecosystem has been well prepared since 2028, roughly, when it was launched this strategic action plan on batteries that encompassed a strategic research agenda to build up this battery ecosystem, a strong battery ecosystem. So this strategic research agenda had several objectives and priorities. So as Michel mentioned, the access of critical raw materials and in general raw materials, development of a manufacturing, a solid manufacturing cell battery industry, upscaling, etc. Skill force is very important. Several assets included also this good framework for funding for regulation. So having said this, it's true that there are a very, very complete ecosystem that has been built not only from the perspective of innovation, but also from the perspective of policy, from the perspective of business, from the perspective of research and innovation. So we have several examples. And the good thing is that now they are working all together, including Battery Europe program, so Bat4U, that is driven by BEPA. So all this ecosystem has to remain, because so far we don't know what's going to happen. So, well, I don't know if this is the question, because if with this ecosystem we can be strong, Europe has to be strong, not only for competitiveness, for growth, for industrial deployment, but also because if we don't have these, then we will be really lagging behind, not only in automotive, but as I mentioned, in other strategic fields. And we cannot afford this for the future. So,
and how about the cash perspective and where we put the cash? Because now we have the community, so to speak. We've seen some disasters in the market, starting with Northvolt, and we discussed, ACC and other difficulties, some joint ventures that crashed, other off-taker contracts that were cancelled. Do you think that? As a speaker was mentioning this morning, that at some point we need to stop spreading money around. We need to concentrate the money, maybe in a few structural projects, to massify.
This has been done because, for instance, the IPCEI says the important project of common interest that are transversal projects based on state aid, so national member states, and also private funding. So this was for boosting the manufacturing, battery cell manufacturing, but there are so many frameworks and funding scenarios as Horizon Europe as well. But the thing is that everything has to be coordinated. And one thing is to have the plan, like this strategic plan with the objectives, and the other thing is the implementation of this plan. And this is where maybe Europe is a little bit lacking of monitoring, of assessing what is going on with the projects, etc. So, for instance, BEPA is supporting European Commission on this. So, if we have the opportunity to continue, this could be, because we just started in 2021. Yeah. So it's nothing. And it's true that has been a lot of funding, and in the EPCI, I think was 6 billion plus 14 billion of private funding, plus Horizon Europe was almost 1 billion of earmark funding for particular projects. Now we have the battery booster that is really an battery booster is an issue of innovation fund, or is an outcome of the innovation fund, and the battery booster is particularly to boost these battery manufacturing capabilities and cell manufacturing. So we have the tools, but we have to implement them well in order to continue.
Last question, but it's a tricky one. Huh? Okay. As a business, you think in terms of portfolio, right? And in a way, you look at your cash and you try not to invest it in the past. You try to invest it in what will generate future value. Do you think that we have the right balance in terms of, investing in scalability versus maybe investing in future technologies, new chemistries, new machinery for future production? I'm thinking of Gen 4, Gen 5, and potentially Gen 6 chemistry.
I think we have to cope with everything. For that reason, for instance, with Recharge, that is the industry association, and BEPA, we've launched a battery deal for Europe. Is here, so I will.
Pictures and
it's
marketing material available
to pledge for it and to advocate for this. And we are, as a part of this strategic vision that contains, first of all, innovate in Europe. So we need funding, and we propose different types of funding adapted to this. So, like what we call the sandbox. So, low TRL projects, disruptive technologies, but we have the foundation track that is Horizon Europe, like now, and then more focused on deployment for manufacturing. That is what we call flagship. So we need different kind of tools and different kind of fundings to cover this. Otherwise, we cannot compare. CATL is 3 billion a year in research and innovation. 3 billion.
I know.
So we cannot compete with this. So we have to keep on fighting.
I just have a quote in mind that one speaker in a panel that was animating a few weeks ago was, I think it was the head of BYD was saying, Europe, you want to catch up with my 10,000 engineers and X patent today? Well, good luck.
Yeah, for sure.
So indeed, we need to show muscle at some point.
Okay.
Indeed.
So just to finalize with this approach of innovate in Europe, then produce in Europe. So for this, we need also funding and a structure. Then buy European. So as you mentioned, we need fair competition with the rest. And then at last, secure European products. Yeah. So it's not...
I sense a bit of regulatory argument in your last words. Excellent. Thank you very much, Marina. It's extremely clear. And reassuring also to see that we have a foundation. Now, of course, nothing is done yet. We know that, but quite good. I wanted to shift back to an aspect that has been always difficult. And Marco, you will tell us. It's the European brand. And you mentioned regulation as well. And what we try to see in strategic raw materials is to say we are, as European, we are sustainable, right? And sustainability is our thing. And I was wondering if you saw, especially within the context of printed systems here and what different projects that you've been surfing on. Do you see it as a cost, as an enabler, the sustainability weight? How do you perceive that, Marco? Can this be taken advantage of as a real opportunity? And maybe connecting also with the regulatory comments from...
Yeah, no, absolutely. Thank you for the question. And actually, I think it's an important point to make, that sustainability is not, it can be another cost depending on the context, of course. But it's mostly meant to provide value, right? So, for me, sustainability is is the same as saying competitiveness. So just mentioning about what I showed before, right? Eco-design. Eco-design, why is that important? It's because at the design phase of a new product is where you decide 80% of the impacts and costs associated to that product. Mm-hmm. So that's why it is important to take into account this sort of analysis, but sustainability in general. And again, sustainability as a sum of the three main pillars. So we have environmental sustainability, but also economic and societal. So I mean, if we didn't have problems with the overall planet, we wouldn't be talking about sustainability. So I really think that sustainability is competitiveness when it is addressed properly.
Mm-hmm. And does it include also the, because we saw the case, which we see more and more in many projects of second life, energy walls, and trying to, find a second life before the, direct, indirect recycling of battery systems. Do you think that this can also alter the NPV of the broader project for industry, the benefits, the margins that we were discussing a bit before? Is that something that can play a role as well?
It definitely plays a role. I mean, I'm just thinking, for example, about the extended product responsibility. That's something that a manufacturer now have to deal with, right? In terms of regulation, going back, is definitely something that they have to be dealing with. So the optimization of the full value chain is really important, and I mean, circularity definitely plays a role in there. The more you can address these, again, from the initial phases or as early as possible, the earlier you address this, the more effectively I think you can tackle this problem. You can reduce cost, or actually you turn these costs into revenues, as I showed before with this circularity assessment. Yeah. Problem maybe being that in order to capture that value, those revenues, other changes have to be made. So I'm thinking about business model innovation, for example. So it's not just not straightforward, but in a context of systemic change, it makes sense.
It's interesting you mentioned this, because when looking at your case, Alfredo, I was wondering about this new business model, just to see if you observe anything a bit disruptive in the sector. I'm thinking of new, battery as a service business models, things like this.
Well, I think they definitely have to be part of the equation in order to provide the answers to the questions we are all posing ourselves during this panel. So shifting technologies, shifting approaches go hand in hand, to my understanding at least. So it is paramount to find model solutions, not only technological solutions, I guess. And even though this was, of course, a project focused on technology development and so on, I think we also can provide answers in that regard because of what Marco was mentioning before. So I think they definitely have to be taken into account with high priority.
Something we didn't explore so much, actually, so far. But I wanted also to turn to Lisa Lou, just to see if you had any specific, I just want to put the weight back on the shoulders of the leader, just to see if you had any reaction to what you've heard so far in terms of, the way forward for the printed systems, but also the key element related to scalability applications.
Thank you. Yeah, it's a bit tough. No, I think we come back in the end a lot to regulations and the need for it to come from up to down, and not only from up to down, but also from up to down. I think it was really interesting to have the opinion of Marina with the BEPA and what is actually happening, because we always have this feedback from us, from downstairs, from the project, and it's nice to have the opinion from above or from another organization that is actually like only industrials. Yeah, in terms of next steps, I mean, especially when you are talking about 3D printing, I mean, that was one of the main vision of our project. And we see that, so I understand what you said, Marina, and of course the opportunity to develop, for example, niche applications. But actually we see that some companies like, I don't know, Abdoulaye, I don't know if you want to discuss this later, but there are projects starting, for example, with you, there are projects starting like in a few months, the European projects that will deal only with 3D printing techniques to manufacture battery packs. So there is this this will from industry to use this technique and develop and bring it to a higher scale and a larger scale. So I think this is new and this is coming. So that's going to be very interesting to see if we manage to bring this to higher level. I don't know if I answered.
Yes, thank you very much. Please, Maria. And that be it a lesson for everyone. I can pick on you just randomly.
Just to say that if Europe is good at something and is not lagging behind at something, is regulation. So we have, so this is good news. At least we are good regulatory agents, and this might be a support. Or at least I want to think that this is a support for innovation. But we'll see.
I would love to hear from the other guys on this. But indeed, before Abdoulaye, maybe just following up on Lisalou's comment about future projects, what's coming up?
Yes, because we have only one other project in parallel and some future project to work on 3D printed with OEM. To reduce the weight and the list of materials inside the pack. So we are working ongoing. So I think we are go ahead to this technology.
Excellent. And what kind of technologies? Is it SLS? Is it FDM? Are these new technologies or?
Not only one, but we are working in many technology in parallel. And after that, we will present to our customer, and they will not choose, but they will go where is better for them. So we want to propose a large part of
potential
avenues. Yes,
yeah.
Of course.
Okay. But integrated within one system, or is it just a line, for example, with different potential options?
For the moment, for system, and after that, we will try to industrial all the topics.
Excellent. Well, looking forward to monitoring this. Please keep us posted.
Why not?
I wanted then to feed back to you, regulation, an accelerator or an obstacle. I like drama. Anyone disagreeing so far? Johanna, thank you.
Yeah, so I would think that the regulation is always a chance. I mean, most of the big OEMs in Europe, they wouldn't do any innovations in this direction if they didn't have to. But for example, this new European battery regulation, it forces the European manufacturers to think about their processes, to think about their products itself, to think about, okay, is it a good idea to bring, let's say, everything from China? Are there possibly other possibilities? How do I certify my parts that they are aligned with the regulation? And I think this is always this is also good for FEV, because then we get contracts for innovation. But also it still gets the industry moving and thinking about sustainability and also about recycling. I mean, the recycling quota that is also mentioned in this regulation is probably quite challenging for the European industry, also because there might not even be other companies who could actually recycle whole battery packs. So there's also a chance for new companies specialized in, for example, in recycling the large scale of battery packs, according to this regulation. So this is always a chance. But it costs money, of course. So there's also a pro and a con.
Yeah, that creates a level playing field. Then you just need to put a bit of cash to incentivize change.
Sure.
I think we already touched upon a couple of key points, but I wanted to hear from each of you, what are the key top 3 barriers to commercialization deployment right now for this kind of system especially, but of course, if you have other insights, would love to. But I want the top 3 because I feel that we always have, the Christmas wish list, sorted out, and somehow you all have, different perspectives, and I would like to see, what are your top priorities in mind? Alfredo, you're on the left side, so
yeah, it's my turn. Well, top 3. It's always a Christmas list, as you were mentioning. So I've never been the top guy for choosing, between the gifts. So I really think that the production, in terms of the whole supply chain of possible integrations, is the main could be the main culprit, so to say. So that's probably my top choice. In terms of other 2, there's really lots of them. So maybe we can agree upon just one by one and then see if we can reach the quota.
I will get back to you for the next 2. You know that.
Yeah, sure. I'll feed off the brain of my colleagues.
Johanna, I would love to have your view here. You seem so comfortable with answering.
I think I have to think about this a little bit longer.
No, the thing is that what you told me earlier was we were talking about your expertise in EVs, your expertise in batteries, but you also told me that, from a process perspective, this is where you have, I think, a more accurate angle to that discussion. And I was wondering, where do we stand there? To make it to the market, even if we're not speaking about large batches like we can have in the automotive sector, we still need to automate, to integrate, to interoperate equipment. There are many dimensions in that. And what do you see the main pitfalls there?
You mean in terms of production? Yeah, if we are not talking about 3D printing, maybe a large scale production possibility is a large amount of parts, a short amount of time. I mean, we just heard that this is probably not the best use case for this technology, but I mean, if we manage to scale it a little bit larger, also the market share could increase. Of course, I mean, automotive is not only VW, not only Volkswagen or Renault. It's also smaller companies, and especially when we are looking about electric cars, there are emerging a lot of companies with maybe only a small amount of cars that are maybe also very expensive. I mean, the Italians are really good at building expensive cars. So maybe there for a super sports car, where you have to squeeze out the last bit of power, for example, this could be a good technology maybe to have like only a small amount of parts, but to have a high technological level and make the best out of what you have.
That echoes a bit what Marina was saying on the specialty products in a way. Thank you very much, Johanna. It's very clear. Marco?
I think I would probably recall what was said earlier about the necessity to really validate solutions, and also not just validate the performance, which is of course is key, but also to validate what the real potential impacts, maybe in terms of savings, for the OEMs, in order then to really transform sustainability as a European unfair advantage. I would say out of necessity, because I mean the raw materials are what there is out there, we know. So I think out of necessity we have to deal with that, and I think that project like this and the validation of this. Both performance and impacts can really make a difference.
Thank you. You all cheated, huh? Only one answer each.
I just follow this.
I will remember.
Okay, so I have to mention 3 barriers.
Yes, if you want to be the best student, yes.
Well, the first one is very easy, and this has been mentioned. Manufacturability, manufacturing, not only cell manufacturing, but in general, equipment manufacturing as well.
But what do you mean there? because we are lacking equipment, because we are still
we are
depending on
lacking
Korean
companies
technology?
that develop equipment.
Okay, yeah.
So we import them from elsewhere.
Korea and China.
China. So equipment, to have the whole value chain,
Mm-hmm.
so we need, manufacturing is the key driver, but then not only cell manufacturing, many others manufacturing, and in general upscaling. Mm-hmm. Then raw materials access, since we have no mining, we have no refining, so it was what we got in Europe, and as you mentioned, in addition, this overcapacity of China, so this adds up to this lack of manufacturing. So these are three. So I didn't cheat.
Amazing ones. Thank you. Thank you very much, Marina. Abdoulaye?
So I think my colleagues say a lot of examples.
A bit more becomes more difficult when you get to the right of the panel.
So for now, maybe we could have some issue with homologations.
Okay. Yeah.
Not for now, but for the future, because we don't work with the same materials and so on. Mm-hmm. So I have no idea now, because we didn't pass to this step, but it could be an issue.
Mm-hmm. Yeah. So certification of your materials for industrial use and things like this.
Yes, yes. And for example, if we need to pass all the thermal propagation test, maybe with the 3D printed, it could be complicated. We don't know how the component will be after 8 years after assembly. Mm-hmm. So we have some questions to manage from what now, I think.
Very much R&D then here. We are still very much on the R&D front.
Yes.
And things that you mentioned that I've heard already a long time ago that are still bottlenecks.
In the future, and we need to make some simulation or some aging test to be sure that it will be okay. But for now, it could be an issue.
Okay. Very, very, very interesting. Thank you very much. Michel, you're the last. Everything was said. Sorry about that.
No, maybe I have other point in terms of barrier. Maybe the timeline.
What do you mean by timeline?
Timeline to react and to be sure that we will be ready with on time. Yes, we will be ready for the next train, I will say. It could be a challenge because we have to cover the full chain from the supplier up to lab certification, but up to the OEM and also in service condition with, for us, with the airport, because for the moment, if we put a battery on the aircraft, you need a dedicated equipment on the floor on each airport, so you have to cover also this point. So it's a full value chain from the supply chain, from the supplier up to the end user, airport, and so on. So it's a big picture and a very large spectrum. Regarding a technical barrier also, because according to our application, it's clear that the weight it's too high for the moment, and it's not so sexy to validate it with our OEM. For the moment, the weight picture is not in line with the market, so it's clear that we have to work on a new technical solution to improve that. And when we will be in line with the target defining by our OEM, then we will be able to answer to them. And maybe the third one will be the OEM itself, because for the moment, as SONACA, we are a tier 1 supplier, not final OEM. So today, we try to propose disruptive solution on existing product. For example...
substitution, basically. Huh?
Yes. So it's a more complex approach comparing to a new project. So if tomorrow Airbus push on the button to say, okay, next aircraft will be 50% electrical power solution and so on. Then all tier 1, tier 2 and the other supplier will follow and will develop solution to be in line. And it's maybe the right time to work on it at R&D level to be sure that we will be ready in time, not only to deliver a solution, but for sure to deliver a certified solution in time. And we know that to qualify a new set of technology, it's maybe 10 years. It's not only 1 or 2 years. So it's, and in this dedicated case, we are happy to know that we have few billions available, I will say, but it's an important point because without money, we will do nothing, and it will be a strong support and help to European industry, it's clear. But we need to be sure that we will be in time and for the next generation of aircraft, for example. And maybe one barrier, it's clear that it's a good question. Do we need to copy-paste Chinese product to try to be competitive? I'm really not sure that it's the right directions, but maybe to select the relevant niche, to be high technology process and so on, and to make the difference through new technologies and new disruptive way of thinking. Because it's clear that we are not, I'm not sure that Europe is well known as a high quantity manufacturer in the world comparing to Chinese product and so on. But it's also an interesting societal discussion, in fact, because we see that our consumption mode is totally different comparing to our parents and our grandparents, and maybe it makes sense to identify how we want to go, in which direction we want to go in the coming 20 years.
And do you have the feeling that this is indeed what we do? Because that what you say is basically what China has been doing well. They had a long-term perspective and they just went for it.
Yeah, for sure, but they have started the job 20
years
years
ago,
or, yes, 20 years ago, maybe.
Before.
So it's sure that, so generally, it depends if the short-term benefits, you know, as a standard consumer, to see I have a benefit close to my nose. So, okay, we switch to Chinese solution, I will say, but it's a new way of thinking, but I'm sure that we need time to switch mine in another way for consumption, and I'm really sure that we need more than 10 years to switch to in another direction for sustainability reason and so on. But for the moment, we know that the competition, we don't have the same regulation rules to follow, so it's we don't play the same in the same rules. So we have a difference at the beginning of the on the new challenge. We don't start from the same scratch, in fact. So it's more difficult for us, but for sure it's a societal discussion. It's linked to the societal behavior, and because who will pay that? It's clear that at the end, if the people that take flight 10 times per year to go in Spain or everywhere, 30 years ago, I'm not sure that our parents have this flexibility with the same price level. So we have to change something to be sure that at the end the equation is that if 50-50, if we have no equilibrium at the end, it will be more difficult to justify.
Yeah. I mean, to be clear, we were also speaking about margins in those different sectors. From a financial standpoint, there are not many big margin players in those sectors. We are speaking of automotive, aircraft industry. I mean, those are not permanent double-digit net profitability margins that we see. So it's, I think that's also maybe something to bear in mind, not to lose the investors as well.
But the way to produce is totally different. If you, for space application, for example, if you compare space in Europe and space satellite manufacturer in US, the story is totally different. And honestly, for the moment, we have a lot of US satellite around the Earth. And now we take the decision to switch to another way to produce component for aerospace application also. And like Thales and so on, they made some difficulties for the moment because they see a new competitors on the market. And now we have to react, to adapt, and to define a new way to proceed for aerospace structure.
Catching up again.
Yeah.
On the vision part, Marina, do you have the feeling that we get more clarity today compared to the launch of BEPA and other, the EBA and so on? Do you have the impression that today we get some more clarity on this longer-term vision, where we're going in terms of...
Just
please,
one
please.
second to
Please do.
Add into what Michel was mentioning about the applications. It is very important to focus the application and adapt the chemistry, for instance, the technology to each application, because maritime application doesn't need the performance of aviation or road, etc., or the low cost of. So this is also a very important factor. We don't have to find the perfect battery for every application. We have to adapt. Yeah. So I think that with these also we can gain margins, but well.
That's still the portfolio approach, huh? And then the right product for the right application.
Okay, so your question was, sorry?
I was thinking of the vision, the long-term vision.
Okay, long-term vision. Well, so far, the long-term vision is a little bit blurred, because since with this Automotive Action Plan, in addition to many other plans that the Commission has settled, like Critical Raw Materials Act and Plan, Resource Act and Plan, well, many framework and funding very well established, but still too fragmented. So in the future, what we don't know is what's going to happen with the battery partnership, since with the wish of simplification from the Commission, so that means reduction of partnerships, with also the competitiveness fund and uncertainty of what's going to happen in the next MFF, so multi-annual framework program.
Basically a new architecture of European programs and European support.
So we don't know. So and particularly since last March that it was launched this Automotive Action Plan, that apparently after a memorandum of understanding of several stakeholders, so BEPA was one of them, also 2.0 Association and CCAM, so is the electric, not only electric, but automotive, autonomous vehicles, sorry, and the Commission. So with this memorandum of understanding was settled several objectives, and one of them was launch a joint strategic research agenda for the automotive sector, and this seems to be the door to a new partnership for automotive applications. So this is very good, because the market and the industry in Europe for automotive application needs that. But this doesn't mean that we don't need a dedicated battery partnership strong to support a strong automation partnership. So the vision at long term is quite blurred right now. We are doing advocacy to support a long-term vision, because otherwise all that has been done during these 7 years will be for nothing with this scheme of a European Battery Alliance, etc., that was launched by Commissioner Sefcovic. It seems like we cannot keep on the job that just started. So it's like if VERSAPRINT project, 2 years before the end, they say, you stop here. You haven't finished. So
do you have the impression that we are not mobilizing enough?
Well, I think every mobilization is needed. For that reason, we have launched this battery deal for Europe. We are preparing a a blueprint. The battery booster is a good tool to support, but every initiative and every support, also from the member states, is very important. That each member state at ministerial level, I don't know. In France, it's at ministry level, but in the other member states, I don't know. But we have to mobilize. Otherwise, we won't have a dedicated battery partnership. That means that raw materials, cell design, cell manufacturing, recycling, dismantling, this will disappear. It only will be integration of the battery already done, the cells, the pack, and for automotive applications. So what will happen with maritime, with aviation, with stationary, very important, with defense? If we just buy batteries,
from China,
we integrate it to defense applications. Do we know who our allies are now? Who will be our allies in 10 years? So this is not only a question of growth and competitiveness and industrial deployment. It's a question of sovereignty, of autonomy, of security for Europe.
That raises a point which I think is, nobody speaks it out, but if you spread the additional cost along the value chain, then someone also has to pay for the rest, and it means that then there is a strategic cost, right? There's something also we were speaking of when talking about the green premium. So does it mean that then we need to pour more cash into it? How? I don't know if you have any perspective on this.
Not sure about the green premium here. Yeah, I would say it's definitely something that we have to take into account. It's fundamental. I also think, like, considering now the whole geopolitical scene, what Marina is saying, is that we're not just doing to outcompete Chinese, but it's just to make a more autonomous European Union, right? And this is fundamental, especially when you have some countries all controlling most of the resources in the planet that are used for the transition. And this also going together with the fact that Europe has always been at the forefront of this energy transition, right? So it's really hard to put these two pictures together, and I think where the friction comes. Yeah, I'm not sure if I answered where the cost goes, but
somehow it became a brand value for us as well. So that's clear. Thank you, Marco. It's funny also, I think, Michel, you were the only one mentioning the infrastructure part. You were mentioning the airport and so on and so on. Yeah. It's funny that it didn't come out so much actually in the discussion today. Any feedback on this point, or you think that it's over dealt with and maybe not that relevant to boost the upscale and the demonstration, upscaling and deployment of those batteries?
You mean the gigafactories, or
no? I'm meaning the charging, the grid, the charging infrastructure, swapping infrastructure.
Okay.
Any feedback on this, or do you think that
I can just mention maybe this alternative fuel infrastructure regulation? I think that's mostly quite relevant, pretty much, to prepare the whole infrastructure. Maybe it's not so specific on batteries and electrification, but it definitely scales to a lot of application, including airports, ports for shipping and everything. So definitely something to take into account, and especially the topic of one of the possible application of battery systems in the stationary applications. It's fundamental. I mean, we know something, at least for those coming from Spain, about the importance of have a stable grid, right? We could see in a country where a lot of renewables are deployed, but definitely that's not a one-stop solution. Together with that, we need stable grids, microgrids, and everything. So to serve the society, we need all sorts of solutions. Also, we don't know that battery or electrification is not the one-stop solution, nor is hydrogen, nor is anything that pops up in your mind. So we really need to, not really to try to compete one technology to another, but mostly I think to understand how they can work together and where maybe this costs for or investments in infrastructure are mostly needed. Yeah.
Thank you. I know I've been pushing a lot. I don't know if there are any other questions. I've been trying to draw you out, but is there any other comment from the audience so far? And if not, I will have a last one. which is a question to each of you on, we've been speaking about many topics, right? We've covered, the trends, future deployment, we've covered the barriers, the policy regulatory aspects. Now just a closing question to each of you on those printable systems, getting back a bit to the core of the VERSAPRINT and brother and sister projects. What would be a key action, very practical, that your organization could actually undertake next to support the validation deployment of this kind of system? Be creative. That's a mental exercise for each of you. Alfredo, you want to start?
Okay, so starting from EFESTO's profile, which is again pretty diverse in terms of all the hybrid prototypes that Luca through the years has tried to conceive and design and engineer. So I think it could be nice as a mental exercise to try to apply it in a retrospective to everything that has been done, and to try to apply it going forward in the next projects in a systematic way, like trying to engineer all of it via the application of these building blocks and these technologies that we've been developing. So just as a mental exercise, could be very interesting.
Kind of standard simulation for everything you do.
Yeah, just make it as one of the standard potential solutions all the time.
Very good. Thanks.
Why
a lot.
not?
Why not? I love it. Thank you. Johanna?
Yeah, if I'm allowed to be creative, not sure whether this is realistic, but I think it would be to push this a little further is to maybe team up with partners and like choose one component, for example, the printed sensor, and try and push this to a further development stage. And I mean, we do have the customers for it, and I think there's also the market for it, the interest in it, because we have only limited space, so small printed sensor would make sense, and maybe try and push this really into the market, concentrate on one component.
Yeah, so to allow that resources are concentrated on making things happen on at least on one part, and then you roll out to the rest. It's a bit the spirit. Excellent. I think realistic as well, probably.
Also going to be very realistic, maybe not that creative, because it's something that we already do pretty much at LOMARTOV in supporting other company and in general technological developments by tackling sustainability early, because for us is one of the best way to transform sustainability from compliance costs to a real advantage. Or yeah, definitely.
So you basically push eco-design services now?
I would definitely. I mean, I would definitely tell companies to consider it, because it's not that common. I think around, and yeah, I mean, just like considering sustainability as a possible advantage and a value proposition more than an obligation. Yeah.
Excellent. So sustainable by design. Then that's. Thanks a lot, Marco. Marina.
Okay, so maybe with my CEA hat, I will say that, well, we are the coordinators of VERSAPRINT. We have a lab particularly dedicated to prototyping in order to test then with very small series what's going on. So, and our approach as RTO is establish collaborations with industrial fabric in France, in the region, in Europe. So we will seek for industry partners that want to go with us to this adventure of 3D printing batteries. So this is the first step. So we have here the head of the lab that I think this is really pushing this approach as well. And with my BEPA hat, I will say that we will keep on looking for a framework, a funding framework in order to deploy this technology. So I will say that it will be this flagship track to promote higher TRL and try to link the development and the outcomes with the industry needs and with the particular application needs for these VERSAPRINT applications.
Do you see maybe a role for new players? Like I'm thinking of the European Investment Bank, of players that are moving into strategic raw materials, they are moving into recycling project investment.
Yeah, indeed. We are working with them, for instance, for the startups. We've carried out the startups forums where we invited BPI in France and other investment tools and investment agents. This is really important to get also private funding for this, but because otherwise it will be difficult only to cope with the European funding.
Thank you, Marina. Tunay?
As Lisa Lou said previously, we are working for the same type of project, and we are looking to have more experience on 3D printing and so on, because maybe you don't know, but the name of OPmobility was Plasticomium previously.
Yes, of course. Yeah.
And maybe we will try to give some advice to our customer when we will have some RFQ on or RFI to propose 3D printed for the new project. So we are working on this technology for the future. Also, we grow up the innovation team to help the innovation and the ecosystem application to manage all this type of subject.
I hope that the European Commission is connected, because it's. So you mentioned that basically this is direct exploitation and that you're creating jobs. You know, what more? Thanks a lot, Abdoulaye. Michel?
For me, it will be eco-design, in fact. So we spent a lot of time, I will say, for eco-design of the product, because for Aeronautics, we develop solution for more than 30 years, I will say. So we replace it, we repair it, and so on. But eco-design for the process itself, it could be an important point to put under control on our side, and we discussed a lot with Marco on this dedicated subject. And for us, it makes sense to continue in this way, because we have identified during the VERSAPRINT project a lot of interaction regarding his team and ours. And eco-design for the product is one point, but for the process itself, to develop a product and to select the right processes, manufacturing processes, to be in line with eco-design sounds a good idea also. Yeah.
That's a very excellent choice and perfect conclusion for the panel, I must say. Thanks a lot for making the time, the effort, and for stepping on stage as well. It's really much appreciated. Please give a round of applause to our speakers. Thank you very much. Thank you. Thank you. Merci beaucoup. Merci.
Thank you.
And of course, thank you very much for your attention as well. Now shifting back to our LOMARTOV colleagues for the concluding remarks, I guess.
Thank you very much, Pierre, and thank you once again for moderating, let's say, the most complicated part of our day. So two discussions that were very interesting, and I think that highlighted a lot of important points. Also, I want to thank very much to our speakers that took the, let's say, the courage to come here in front and present results. It's not easy. I see that one of the main topics was cost. So we go round and round the cost, and let me add a bit more complexity to the issue. I've been in a lot of events lately on different topics. So you talk about batteries, you end up talking about cost. You talk about fisheries and aquaculture, you end up talking about cost. You talk about remediation technologies for environmental pollution, you talk about costs. So everyone is fighting there for the money. So one thing that I want to add to the panel discussion that we can be disruptive about in Europe is maybe finding a way, because I'm thinking about this a lot of times, finding a way for, instead of adding more money to generate innovation and value, to maybe add more value to the money that we have, because apparently as much as we push, at some point we cannot get more than that. But in any case, if someone is working in the room on a breakthrough money generation technology, I think that we found the next project that everyone will sign up for. Joke aside, when we kill the cost elephant in the room, I think that you have found a lot of ideas. You have found other ways to go on with your work and with your, let's say, improvement and innovation and research. And I think this is very good thing. Also, this is last month for VERSAPRINT project. And I know that every time we are in the moment like this, for all the team, this is very tiring because now there are all the deadlines, all the deliverables, reports, things that you want to solve very, very last minute. And I want to take this opportunity to stop for a moment and make you celebrate a bit the moment. Because you are having so many years of work together. There were a lot of challenges, but there were a lot of achievements as well. You've did a lot of progress, and you generated one thing that I think it's most valuable now. You generate ideas for the future. So don't forget those in the craziness of reporting everything to the Commission. Don't forget all the ideas that are in your mind and you can say at this moment, maybe next time I will do it better because I can do this thing. And remember that thing for the next project. Doing better things. So here we have an evaluation survey that is very relevant for us at LOMARTOV to understand how you have felt during the day, what you have liked or not liked, what are your recommendations for us for the future, and what we can improve, and what topics you would like us to address in future events. Because yes, VERSAPRINT is maybe finishing, but we will continue to organize events in this field, and we would like to know also what are your interests about this. So you can fill it in, shouldn't take very, very long. You can also scan it and have it on your phone and maybe fill it in later if you feel more comfortable this way. But we will very much like to hear also from the ones at home. So don't feel excluded. Let us know how you have seen things without being able to drink the coffee with us here in Grenoble. Also, I would like to thank CEA and Lisa Lu for all the support in organizing this event and providing us the venue and walking us through everything that we can find in Grenoble. And I also want to thank my team, my LOMARTOV team. We are here spread around the room. This event is a team effort, just like VERSAPRINT. Before going to the very final closing remarks, that will be maybe a bit more technical, but don't wait them from my side because I cannot do that. Lisa Lu will be the one doing this. I promised that we will be having a graphical representation of the day. Actually, sort of feuilleton, I think, because every session was graphical represented by Blanche, that is our graphical designer. She was behind there all the time. You maybe didn't notice her. You can turn back and see her. Hi, Blanche. Thank you very much for doing this drawing. So this is, first of all, this is nice because you have in a visual captured everything that you discussed during the day. But also this has another value. It's important because it is how a person that doesn't have a technical background will understand and will see your discussion and your messages. And I think that this is something that people on LinkedIn usually see and understand. No matter how technical are our posts, in general, the others will kind of capture only part of it. So we had a session dedicated to VERSAPRINT. So we heard about a lot of elements that are important and were important for the project during its lifetime, and also looking forward to the future of the battery manufacturing. We were talking about, of course, the 3D printing and the freedom of design, about the safety, the circularity, the cost. Well, everyone was mentioning the cost during the day, but also we were talking about security, health, green transition and decarbonization were also important, let's say, key concepts. And one thing that it's very important, and I'm very happy that Blanche put it in this graphical representation, is that it was an effort of 3 years and 10 partners. Let's not forget the people behind this work. Going to the next session, you will be able to see everything online. So if you want to deep dive and find where you have added the key concept to the drawing, you will be able to do it afterwards. So we went and explored the cell, we explored the cell unit, and we explored the module. So we go from small to, let's say, bigger developments, and we talk about temperatures and coatings and water-based sustainable inks and future flexible substrate, sorry. We talk about the cell unit and the performance, the cooling, the bus bars. That was the first time I heard about the bus bars. Thanks to VERSAPRINT. Now I know something new and something more. Increased lifetime and increased surface, something that has to be easy to dismantle, so to recycle in the end. And every time a bit of next steps and looking forward, because a final event, this is what it's for. And then we were talking about the module. To be adaptable cross-sector, so already anticipating a bit the applications, integrating all the components in a safe casing, the lightweight and the fire-resistant, the gas management, venting, anti-ice, aeronautics. So a lot of concepts. That means that you worked a lot and you were considering a lot of variables and elements. So I hope this pays off now that we are closing the event. We can go to the next session. All this for me, it's the same surprise as for you. So we discovered together. So we were talking about the European research synergies, because VERSAPRINT is a project, but it's not working in silos. It was a cluster or many other clusters out there that you can connect with. And it was a discussion here that maybe working together we can go faster. And well, this is another way to add value to the money that we have. So here we have objectives. So objectives that are much more ambitious than for a project and need to integrate a lot of other projects, ideas, and let's say targets as well. We were talking about the toolkit to be adapted to applications, to different uses, and so on. We were talking about knowledge sharing, also with the external research community. We were talking about the communication, that it's important with the EU and for the investment, and also to scale up manufacturing, but also IP was mentioned. That can be a potential barrier, but can be also a motivation for some. And the need to have, let's say, the outcomes communicated, and to have these white papers that modify the state of the art with every project that we advance and we go together. I'm not talking about the cost again. We are killing the cost because this was covered enough. In the end, we need expertise from whole Europe. So going back to what we can do better in Europe, and to keep the cluster connections after the projects in the cluster are ending. I think this is very, very important, and I think in the end this is the aim of the cluster, to keep the narrative going. And we can go to the next one. And here we had some discussion on cross-sector and sustainable deployment. So here we were talking about automotive. We were talking about where is aeronautics, some marine applications. So we have different ways to exploit VERSAPRINT results. We were talking about market here a lot, about validation, about constraints, challenges, the life cycle thinking and the life cycle validation as well. Analysis, a lot of analysis, replicability, and also I see several times, I think, or maybe I just imagine, KPIs. We repeat several times the KPIs. And Here we also had a nice discussion on how these synergies can help and how we can, convert or use these costly research results into some niche application and to find ways to build our own market and to find the one that it's better for us and for what we work here. And going to the last one, I think it's the last one, right? Confirm from, yeah, perfect, is the last one. So this last one was the industrial roundtable. And here it is how your discussion looked like. And I'm going to read only the very, very big concept because I think they are quite relevant. Cost aside, we talk about regulation, we talk about scale up, we talk about standardization, and we have the tools we need to coordinate and implement them well. So I think in the end, this is when a project ends, we have a lot of results. The thing is what we do now with all of these. So all this progress, how will be developed after this ends. Of course, there are barriers also related to access to raw materials. Well, people will only pay more for extra value. So again, we are talking about value and how to motivate the others to buy, let's say, more costly and to support our work being more sustainable and being more, let's say, fitting to the regulation. There are limits to production at large scale, but it's a good for niche applications. So again, there are, let's say, pros, but there are also a solution to this. And one important element is it was that it reduces waste or doesn't generate too much waste. And I think this is also very important thing. Can we compete with China? Well, this is still a question that will remain out there. I think one project cannot answer it. Probably we will need much more than that. In any case, this is our graphical representation. This is how it looks like if you see it from very, very up and trying to understand it very, very generically. And of course, there is much more behind it. And the much more behind it is also the video of the day. So just to announce that we will be having all the sessions, actually all the sessions were recorded, and you will be able to see everything online. So if you want to share with your project partners, I refer to the projects that were here, and maybe they want to share with the other colleagues, and also with the European Commission, especially the Roundtable. Maybe they will be interested to hear what we discussed here. This will be able in a week or two. We will put it online, and you can use also this full recording if this is not too very technical and too summarized for what you need. And now it's time to give the floor to Lisa Lu, VERSAPRINT coordinated. We started with her in the morning. We closed the day again. And let's see from your point of view how you have seen now that VERSAPRINT final event comes to an end. How you've seen it.
Thank you. Yeah, another tough question. Actually, I was just coming up there to say thank you again. Yeah, today was a very important point, as we mentioned before. So this is the end of our project. Yeah, the goal was to actually show our results and to discuss with you and especially the people from outside of the project to discuss if you are interested, what are your remarks about what we did and what you thought about what we did. And if you are interested to go on working on them with us. I was scared that we would see on the slide there who will pay. So I'm happy that it's not the main message here. Yes, I think the next steps. So the next steps for you is to share if you were interested. Look up for our results. Most of them are public, so please feel free to look more in details our results. and to come to us. You know now who we are, to discuss any new opportunities. And the next steps for us, for VERSAPRINT, is to finish really this project, because it's not completely finished. We still have to do the last step and to report to the European Commission, which will be tough. So we do have our General Assembly tomorrow, so keep keep your energy from today. And yes, I want to thank again the team of LOMARTOV for organizing this event. This was a collaboration with you since the beginning of the project, and it was a pleasure to work with you. And Céline also for coordinating the first part of the project. And thank you, all of you, the partners, and all of you for coming and talking today. And the last point will be completely different subject for the partners of VERSAPRINT. If you could all join me here at the end so that we can discuss the next steps all together. And for the rest of you, I wish you a nice evening and see you soon.
And the very last point, since we are a sustainability company, if you want to leave the lanyards at the entrance because we reuse them, will be very great. You can keep the badge as a souvenir from our event, but the lanyard can be recycled. Thank you and have a great evening.